Alright, here we're going to be learning about solving inequalities with variables on both sides. So far we've only dealt with inequalities where the variables are all on one side of the inequality symbol. So it could look really complicated. And it could have more than one variable. But they've all been on the same side of the inequality sign. They're all on the left side in that example. Now we're going to change those examples so that something is going to move over to the right side, which is going to change how we deal with this. So it's going to look something like this. Might still have more than one variable on the left side, but one of the variable terms is going to be on the right side, like we're seeing here. We have some variables on the left and one variable term on the right. This is the kind of example that we have to be prepared for now. It's going to change how we deal with this. Actually, we're going to start it out the same way, though. We're still going to distribute and combine like terms first on either side. Distribute and combine like terms on each side if possible. Sometimes you won't have to. But first we're just going to deal with one side, and then we'll start moving stuff from one side to the other. We're going to move all of the variable terms to one side using inverse operations, just like before. And then it's going to boil down to just a two-step inequality, which we should be really practiced at by now. Always remember, flip the inequality sign if you multiply or divide by a negative number on both sides. So there's times where we distribute, which is just multiplying on one side. That's not what we're talking about. It's only if we multiply or divide by a negative on both sides of the inequality symbol. Alright, so here we see our first example where we have a variable on the left side and a variable on the right side. We have 9x on the left, we have a 6x on the right side. This is different from before. We're not just going to combine these like terms because they're separated by that inequality symbol. Instead of just adding those together, we have to think about how to cancel it out on one side so that we're allowed to bring it over to the other side. What allows us to do that is the inverse operation. So right now, I almost want you imagining that with a plus sign in front of it, like that's a positive 6x. So even though that is multiplication, we're normally used to dividing there. We're not going to divide here. This is not the correct step. We're not dividing. That would only cancel out the 6. We want to cancel out the entire 6x to bring it over to the other side. We're going to subtract it. We're canceling out a positive 6x by subtracting it on both sides. Positive 6x and minus 6x cancel each other out. That's really 0, but we don't have to write the 0. We just write the other term, the negative 110. And then that allows us to bring it to the other side. We really just are keeping it balanced by doing it on both sides. So we minus 6x on that side also. That gives us 3x. Alright, so that's very different from before. Before we would have just added those together. Now we have to cancel it out on one side, so we have to do the opposite sign there. We're going to do a minus 6x on both sides to make it into a minus 6x there, and eventually that changes into 3x because we're subtracting. Now we have a two-step inequality. These ones we should be really ready to... Oh, I don't know why I wrote a 3 there. Sorry. That's supposed to be a 2. It is 3x, but it's minus 2. That's our next step. We're going to cancel out that minus 2. I'm going to box this 3x just as a visual to say I'm going to deal with that later. For right now, I'm going to cancel out the minus 2 by adding 2 to both sides. The 3x comes down, and that's less than now negative 108. Same last step as before. This is multiplication. We're canceling out just the 3 here, so we're dividing away that 3 to cancel the multiplication. That gives us x is less than negative 36. That is our final set of solutions. All the numbers smaller than negative 36. So now I'm going to put that on the number line. I'm going to put negative 36 somewhere in the middle. And let's say negative 40 is to the left, negative 32 is to the right. And we're going to have an open circle above negative 36, and we're talking about all the numbers smaller than negative 36. So that arrow goes off to the left side. Alright, I'm going to start this the same way. I'm going to draw that line just to distinguish between my two sides. Again, our first step is always distribute or combine like terms first, just on either side. I can't distribute here, but I can combine like terms. I have this 9 here. and a minus 15. I can put those together before I do anything else. The negative 20x is just going to come down. 9 minus 15 is negative 6, so I'm going to write that as minus 6 in my next step. I can also combine the stuff on the right side. So I'm not moving stuff between sides, I'm just simplifying the stuff on the left separately from the stuff on the right. There I'm just going to subtract 15 minus 11 is 4, that becomes 4x. Alright, now I see that I have a variable on the left and a variable on the right side. I want to bring them all to the same side. In general, I'm going to bring them all to the left side. So I want to bring my variables to that side. You don't have to, but I'm generally going to. So I want to think about, how do I cancel out this 4x? How do I get rid of that positive 4x? Well, I'm going to subtract it. I'm going to do the opposite of a positive 4x. I'm going to do minus 4x there. I don't do anything with this minus 6 here. That's just going to come down. Because those aren't like terms. I really can't combine something with an x with just that number by itself. But here I can subtract. Negative 20 minus 4 is negative 24, and that keeps the x attached to it. On the right side, this might be a little bit confusing, but really when I say these cancel out, it just turns into 0. Since there's nothing left there, I actually want to write that 0 in this case. Here, that also turned into 0. It would have been 0 minus 110, which is just that negative 110. So you don't need to write it in that example. That's why I didn't write it here. But here, I need something on this right side, and that's the only thing left there. There is nothing left. It's just 0. All right, now I'm down to a two-step inequality, so I'm going to solve for x here. I'm going to add 6 to both sides. The negative 24x will come down. Positive and the negative 6 cancel each other out. And on this side, 0 plus 6 is just 6. One last step here, we have multiplication. Don't get thrown off by the fact that this is going to be a decimal. That's okay. Divide by negative 24 on both sides. Make sure you include the sign when you divide there. It's divided by negative 24. So we get x on the left side by itself. We get negative 1/4. If you'd like to write that as a decimal, that's fine too. If you write negative 0.25, that's okay also. And we divided by negative on the left and on the right, so we have to flip the sign. So x is greater than negative 1/4. I'm going to put that on the number line. Negative 1/4 will go there. Just to the left will be negative 1/2. Just to the right will be 0. And we're talking about all the numbers that are greater than negative 1/4. So we don't fill in the circle. It's not greater than or equal to, it's just greater than. Oh, sorry, I lost that sign. It is greater than or equal to. So we do fill in the circle. It could be equal to that. So we have a filled in circle and all the numbers that are greater than negative 1/4. All right, here we're going to shade all the solutions that satisfy, or all the numbers that satisfy that inequality. First I want to solve it. So I have variables on both sides again, but I also have some like terms that I want to put together first. I have 7 and a minus 2. Neither have an x, so I can put those together. Those are like terms. I'm just going to bring the 7x down for right now. 7 minus 2 is a positive 5, so I write that as plus 5. On the right side, I have two terms that have an x. Those are like terms. 2x plus 3x is 5x. The minus 3 doesn't have any like term to combine with, so it just stays the same, just as minus 3. Now I see I have variables on the left side and on the right side. I'm going to bring them all to the left side, which means I'm going to cancel out the one on the right side. I'm going to cancel out this 5x by doing minus 5x on both sides. That cancels out. Really gives us 0, but we don't need to write that. We're just left over with this negative 3. And then 5x subtracted from 7x is 2x. And we rewrite the plus 5. Now we have a two-step inequality. Cancel out the adding and subtracting first. We're going to subtract the 5 to cancel out the plus 5. We get 2x is less than or equal to negative 8. And then one more step, this is multiplication, so we're canceling that out with division. So we get x is less than or equal to negative 4. We don't need to flip the sign. That's positive 2, that's positive 2. We don't care that this is a negative 8. It's only if we multiply or divide on both sides by a negative number. So x is less than or equal to negative 4. We're looking for numbers that are less than or equal to negative 4. Well, negative 4 is equal to it. And then all the bigger negative numbers are going to be smaller than negative 4. So it's just those three there. Last one. We're going to solve this inequality, then select the numbers that are not solutions to the inequality. This one looks complicated. Especially the fractions make it look complicated, but those fractions are going to go away after the first step. We're going to distribute first. We're going to take this negative 1/5 and distribute. We're going to take this 1/2 and distribute on that side. You have to distribute before you combine like terms. That's multiplying before adding or subtracting. That's really just order of operations. So always distribute first, then you combine like terms on either side. Then you start bringing the variables to one side. So here we're distributing the negative 1/5 times 5, that's negative 1x. Negative 1/5 times 40 is negative 8. 1/2 times negative 10x is negative 5x. 1/2 times 14 is 7. And then I'm going to rewrite that minus 3. Nothing really affected that yet. Although that is going to be my next step. I'm going to combine those. Those are like terms. 7 minus 3. Nothing about the left side changes, so I'm just going to rewrite the stuff on that side. Negative 5x stayed the same. It's really just a subtraction, which changes into a positive 4. Now I want to combine stuff all to one side. I want to combine all my variables to one side. So I'm going to cancel out this negative 5x. I'm going to cancel it out using the opposite of a negative 5, which is a positive 5. So you do plus 5 to that negative 1. That gives you 4x. Still minus 8. Still positive 4. And now I have a two-step inequality. I'm going to always deal with the adding and subtracting first. I'm going to keep this the same for right now. The 4x is going to come down after I cancel out the minus 8. If I add 8 on the left, I've got to add 8 on the right, so that's going to change into 12. And then one last step, I'm going to divide by that positive 4, so I don't flip the sign. I just divide and get x is less than 3. Those are the solutions, all the numbers smaller than 3. But I'm picking the ones that are not solutions. So anything that's not smaller than 3. 3 is not smaller than 3. 4 is not smaller than 3. 15, 22, those are not smaller than 3. Alright, so this added step of moving stuff from one side to the next is very different from what we were doing before. I really want you comparing that to combining like terms. If I have like terms next to each other, you follow the operation that you see. If you have like terms that are separated by the inequality symbol, you can't just add those together. You have to cancel them out on one side so that you're allowed to bring it over to the other side. You do the opposite of what you see there. Hope this helps. Use it for the practice on the back.